My name is Nikhil Sai. Today I am going to present a Newton's law of cooling, which is an important concept in heat transformer. Newton's law of cooling was introduced by Isaac Newton in 1701. This law explains how the temperature of an object changes with time when it is exposed to a surrounding environment. In simple words, it tells us how fast an object cools down. This concept is widely used in physics, engineering, and even in daily life situations. For example, when we keep hot tea outside, it slowly becomes cool. This process follows Newton's law of cooling. Definition: the law states that the rate of cooling of a body is directly proportional to the temperature difference between the object and its surroundings. This means if the temperature difference is high, cooling will be fast. If the difference is small, cooling will be slow. Mathematical formula. The mathematical expression of this law is dt by dt equal to minus k into T minus Ts. Here T is the temperature of the object, Ts is the temperature of the surroundings, and K is a concept called the cooling constant. The negative sign indicates that current decreases with time. Let us understand each term clearly. T represents the temperature of the object at any time. Ts represents the surrounding temperature, which is assumed constant. K is a constant that depends on the nature of the object and environment. T represents time. So this equation helps us calculate how temperature changes over time. There are many real life examples of this law. First, cooling of hot tea or coffee. Second one, cooling of car engines after switching off. Third one, the human body cooling after death, which is used in forensic science. This explains how important this law is in practical situations. This is the question. In this problem, the surrounding temperature is 20 degrees Celsius. A body cools from 100 degrees Celsius to 80 degrees Celsius in 10 minutes. We need to find the temperature after 20 minutes. This type of problem can be solved using Newton's law of formula. First we write the formula, then we substitute the given values. Next we calculate the constant K. Finally we find the required temperature after 20 minutes. This step-by-step method helps us get the correct answer. Applications. Newton's law of cooling has many applications. It is used in forensic science to estimate the time of death. It is used in thermodynamics for studying heat transformer. It is also used in industrial cooling systems and engineering processes. And the conclusion is Newton's law of cooling explains how an object loses heat over time. The rate of cooling depends on the temperature difference between the object and surroundings. It is a simple but very useful law with many real life applications. Thank you.